Hey everyone, so here's the next step in the problem. Okay, so here's what we know so far. Up to this point, we know that lead chloride is the excess reactant. We have 0.4298 moles of lead 4 chloride, and we know that ammonium phosphate is the limiting reactant. Based on our previous work, we already figured out that we have 0.2550 moles of ammonium phosphate. Okay, so the next question in the problem is asking us to figure out how many grams of precipitate form in the reaction and how many atoms of metal remain. And then the next question is how many molecules of reactant remain unreactant. So these are the questions that we're going to answer today, and I'm going to try and keep this video a little bit shorter. Okay, so here is our balanced reaction. So let's figure out the precipitate, right? In order for us to figure out the precipitate, we need to figure out which one of these four compounds is the precipitate. Remember that precipitate equals the solid. This is the one that's going to come out of solution and form a solid. So I'm going to show you how to do one, and then I want you guys to try and pause the video, see if you can figure out the rest. Okay, so in ammonium phosphate, right, what we're going to do is we're going to take a look at our solubility table. Now remember that across the top we have the positives, and then down the left we have the negatives. So all you got to do is do like a multiplication table and figure out where everything is. So ammonium, if you look, is right here. Okay, phosphate, if you look, is right here. And if you go all the way across, which is right next door, right, you're going to see that this guy is insoluble, is in soluble state. So what that means that this guy is in solution, so he gets an AQ. Okay, go ahead and pause the video, do the same thing for the three, and then when you guys come back, I'm just going to go ahead and add them so we don't make a video too long. Okay, let's go ahead and take a look, and I'm going to go ahead and just fill in the symbols for all three that are remaining. And what we should have figured out was that our precipitate is this solid, which is the lead phosphate. So the precipitate, right, is the one that forms the solid. So when the question is asking you how many grams of precipitate form, right, what we're looking for, is this guy. We're trying to calculate how much of this guy is going to form. Okay, right here. Now, since we know the product that we're looking for, then we got to figure out what the mole ratio is, right? So let's take a look at our mole ratio. In order for us to calculate a product, we need to take the mole ratio from the product that we're looking for over the limiting reactant, right, which I'm going to abbreviate. So we're looking for this product, right, and I'm going to do this in red now. We're looking for this product, okay, and we already know that this guy is our limiting reactant. So I'm going to take the mole ratio that exists from here to here, right? So that gives me a 1/4 ratio. Now, I cannot write it like this. I have to write it in expanded form. So that means that I'm going to write it as 1 mole of lead phosphate over 4 moles of ammonium phosphate. Okay, once we have that mole ratio set up, then we can calculate, right? This is actually a lot shorter process than the last one. So if I'm going to use my mole ratio from my limiting reactant to my product, then I'm going to use the amount of limiting reactant, and that's going to be my starting value, okay? I don't know why my pencil keeps doing that, but okay. So I'm going to start off with that amount, okay? So 0 0.2550 moles of ammonium phosphate. I'm going to put that over 1. Now, I'm going to multiply this by that same mole ratio, okay? So I'm going to set it up so we have a difference in color. So 1 mole Okay, then I'm going to put it over the limiting reactant. Okay, now when you set this up, right, you're going to multiply everything straight across. Okay, when you do that, these units are going to cancel. All right, so let's simplify this now. 0.255, right, 0, times 1 mole of lead 4 phosphate becomes 0.2550 moles of lead 4 phosphate. That's supposed to be a 4. Okay? 1 times 4, that gives me 4. Remember that this unit is canceled, so the 1 and the 4, or the 4 no longer has a unit. Okay? The moles of ammonium phosphate were canceled, so the only unit that didn't cancel was the moles of lead 4 phosphate. Okay? So when you multiply everything out and you divide, you should end up with 0.06375 moles of lead phosphate or lead 4 phosphate. Okay? This is how many moles of precipitate were formed. Okay? Now, the question is asking for grams, right? So we have to do one more step. We're going to take this number now, okay? Because this is in moles. And we're going to put it over 1 to convert to grams. Now, remember that anytime you see the word grams, that's got to be the red flag to say, hey, I need to use mass, right? So I'm going to use the molar mass of the compound. So again, I'm not going to go over molar mass in this video. You have a video on how to find molar mass. So go ahead and review that one if you need to, but I'm just going to go ahead and put the number. Now, I know, because I did the work already, that 1 mole of lead phosphate, lead 4 phosphate, has a mass of 1001.48 grams per mole. Okay, so what that tells me is that 1 mole of lead 4 phosphate has a mass of 1001.48 grams. Of lead 4 phosphate. I want you guys to take a notice and notice that even though I know the units, that I keep writing them down. Okay, please make sure to include all your units. Okay, remember again that everything multiplies straight across and then you divide the last 2 numbers. When I do that, this unit is going to disappear. Okay, so multiply straight across 1001.48 times 0.06375 gives me 63.844 grams of lead 4 phosphate. Now, here you have 1 times 1. That's just 1. If I divide by 1, I get the same number again. So this is how many grams of precipitate should form in that reaction. Okay, so what did we do? So we took the limiting reactant and we figured out the mole ratio, right, to the desired product. Once we figured out, we took the starting amount of our ammonium phosphate, right, which was here, multiplied by that mole ratio, all right, and then we ended up with moles of lead 4-phosphate. Once we got the moles, we used the molar mass of the compound, which was 1,001.48 grams per mole, and we converted it to grams of lead 4-phosphate. So now we know how many grams of lead 4-phosphate were formed. Okay? All right. That second question is a little bit tricky. Okay, so let's take a look at it. We know that lead 4-phosphate is made up of a metal and a compound, right? Or nonmetals. All right. We know that lead is our metal, right? So what the question is asking you of how many atoms of metal remain, what I want to figure out is how many atoms of metal exist within the amount, excuse me, within the amount of lead 4-phosphate that we have calculated out. Okay. So it's still stoichiometry. It's just a little bit different. Here's what I'm asking. What we're going to do is we're going to find the ratio within a single compound, right? Before, we've been doing ratios within chemical equations like this, okay? But you can do the same thing within a compound. So for example, this chemical formula represents one molecule of a substance, right? So in one molecule of lead 4-phosphate, right? How many atoms of lead exist? Well, that's easy to figure out. All you have to do is take a look at the subscripts, right? So if I wanted to figure out what the ratio is from lead to lead 4-phosphate, right? I just got to take a look at this little number right here. This little number right here tells me how many atoms I have. That tells me that I have 3 atoms of lead, right? Or let's say I want to figure out how many atoms of phosphorus there are, right? Or oxygen. So in one molecule of lead 4-phosphate, I have, for example, 16 atoms of oxygen, right? Because of these two subscripts. So you're still finding the mole ratio, except now you're finding the ratio within a single compound instead of a chemical equation. Now, how does that apply to this? Well, if I know the number of moles, right? Moles of lead 4-phosphate. I know that in 1 mole right, of lead 4-phosphate, we have 6.022 times 10 to the 23rd molecules. Right? Now you use Avogadro's number. Okay? So once we have that set up, that's going to cancel. I'm going to multiply straight across, divide at the end, and you'll end up with this answer. 3.839 times 10 to the 22nd molecules of lead 4-phosphate. Okay? Now, once we have the molecules, then we multiply by the mole ratio we just figured out, and we calculate the number of atoms. I know that in 1 molecule, and yes, I keep writing it out, right? That contains 3 atoms of lead, right? So I'm going to take that number, and I'm going to multiply it by 3, and that's going to give me the number of atoms. And there it is. Okay. This one's a little bit trickier, right? We haven't gone over this process in detail or really much of how to calculate the atoms. But this is how you do it, right? It's just doing stoichiometry on a slightly smaller scale. Okay. The last question was, how many molecules of reactant remain unreacted? Okay. So unreacted means that you're going to have leftover materials, right? Which one is going to have leftover materials? The excess or the limiting? The answer is this guy's going to have the leftover materials, right? It's going to be the excess. Now, this is more of a logic question, right? Here it's asking you to figure out how many molecules are going to remain unreacted. That means how many of the molecules of the lead 4 chloride or the excess reactant are not going to undergo chemical reaction. Now, if we scroll back up to our previous calculations, right? Let's see if we can find it here. We converted our moles of lead 4 chloride, and then we calculated our need of lead 4 chloride. So this is how much lead 4 chloride this reaction is going to use, right? This is our need. Now, what we're going to do is we're going to compare that to the half, or how much we actually used, right? So let's figure out that difference. If I have 0.4298 moles of lead 4 chloride. Okay, let me erase real quick. Okay, and I'm going to need 0.1913 moles of lead 4 chloride, right? If I take that difference, then I can figure out how much is remain unreactant, because this is the amount the reaction is going to use, right? That's what we calculated that we're going to need. So when this reaction goes forward, we're going to use this much of it, okay? So let's figure out the difference. That's going to give me a difference of 0.2385 moles of lead 4 chloride. Now, to convert that to molecules, you're going to do exactly the same thing. You're going to use Avogadro's number, okay, which is a 6.022, and you're going to pretty much set up this problem here, okay? I don't want to do it twice because I'm trying to keep the video short, but you would take the number of moles, you would use Avogadro's number, and you would figure out how many molecules remain unreacted. Okay, I will post the answer to this question in the comments so that way you can double check your work. Okay, guys.